All right. Well, hello everyone, and welcome to today's webinar on space-based solar power. I'm Jason Rainbow, Senior Staff Writer and Head of Business Intelligence at Space News, and I'll be moderating our discussion on how a technology that's been studied for decades now finally seems to be on the verge of becoming reality, even if it still sounds like science fiction. For those new to the concept, space-based solar power, or SBSP, is about harvesting solar energy in space and beaming it to the Earth using wireless power transmission, either via microwaves or lasers, to provide continuous clean energy anywhere on the planet. It could be fed right into the grid or even power remote military operations, for instance. Recent industry and technological advances, from enabling cheaper, easier access to space to modular in-orbit assembly capabilities, are aligning to make this vision more viable. And as we're here today, multiple ventures are now pursuing different pathways to get there. SBSB certainly seems to be having a moment. Around $100 million of private capital has been invested in space-based solar power over the last 6 months or so. So today we'll explore the evolving technologies, business models, policy frameworks, and the big questions around regulation, financing, and security. But before we get started, I would like to thank our sponsor, Deposition Sciences, Inc., and here's a quick word from them.
This webinar is sponsored by Deposition Sciences, Inc., a Lockheed Martin company that specializes in space materials. Deposition Sciences, Inc., DSI, offers their state-of-the-art sunshade, a thermal control material available in both free film and tape version, as well as other space materials. To learn more, visit their website at depsci.com or call 707-573-6700.
Thank you again to Deposition Sciences. And by the way, this webinar is being recorded and will be available later today on our website, Space News. So let's meet our panelists. We have John Mankins, former NASA physicist and inventor of the SPS Alpha concept, an enormous geostationary platform for delivering gigawatts of power that's being developed in partnership with an Australian startup. We have Martin Soltos, co-CEO of Space Solar in the UK, which is also developing massive platforms for high orbits. Colby Carrier, Head of Business Development, Regulatory and Policy at Etherflux, a US startup planning a low Earth orbit-based demonstration next year for far smaller satellites. And Karen Jones, Senior Space Policy Analyst and Economist at the Aerospace Corporation, author of multiple market and policy studies on this topic. And we'll also open the floor for audience questions toward the end, so please use the Q&A box at any time to submit those, and we'll get to those a bit later. All right, John, let's start with you because you've been involved in SBSP for decades, from NASA studies to your current work on SPS Alpha. Can you walk us through that concept, how the technology landscape has evolved over time, and why you think the stars, technologically and commercially, are aligning now?
So thank you, Jason, and thank you for the opportunity to participate in this panel with such distinguished experts in the field. So I'll start with the second part of your question, which is why now rather than earlier, and the answer is really embedded in all of the huge changes that are taking place in the space technology and space systems landscape right now. In particular, the emergence of reusable launch systems that have reduced the cost of access by on the order of magnitude, and a half dozen new ventures are underway, both government and commercial, which promise still more reductions in cost, maybe another 90%. At any event, the cost of access to space is going down from $10,000 to $20,000 a kilo to well below $1,000 a kilo, maybe as low as $100 a kilo. Secondly, and taking advantage of this capability, there have been tremendous advances in the mass production, the manufacturing of space systems, going from $100,000 a kilo for a one-of-a-kind to less than $1,000 a kilo for thousands of satellites. And for space solar power, whether it's a modular approach like a laser, or an integrated but aggregate approach like microwave, making these large systems out of hundreds of thousands of modular pieces, maybe millions of pieces, completely transforms the cost of those systems. And lastly, and closely related, because of low cost launch, the cost of deploying these space systems, including the robotics, the in-space transportation, is radically changing right now. And so this combination of access, manufacturing, and deployment is enabling the boom in space solar power right now, in my opinion. Space solar power by means of arbitrarily large phased array, the SPS alpha concept, is one of the first of the modular approaches. I came up with that in 2011, and it was looked at under a NIAC, NASA Innovative Advanced Concepts program at that time. I've been pursuing it for the last 12 or 13 years. It leverages all of these advances even before low-cost launch was really available. Nevertheless, it anticipated that low-cost launch was feasible and would come, and it integrates into a large platform over 1 million modules, on average about 5 kilos in size, and so it basically produces a stupendous number of beefy CubeSats and other materials and other structures and so on, and integrates them together to make a single large solar power satellite. There are a number of other concepts, of course, and I'm sure we're going to discuss those as well.
Yeah, could you give us a quick sense of just the scale of this project once it's all built in orbit? You know, you said that it fundamentally requires no new R&D, only scaling proven technology. Could you give some examples of those mature technologies?
So in the case of SPS Alpha, it was created to take technology out of the lab and put it into applications. It uses planar microwave wireless power transmissions, transmitters. It uses simple planar solar arrays. It can be plugged into the microwave power transmitters locally on a scale of about the size of a dining room table. It integrates that with a set of reflectors that redirect the sunlight, and those the connection is all a node and truss approach, such as was demonstrated back in the 1980s. The reflectors are heliostats, which is a concept as a physical question, is used in solar tower systems in multiple countries. Now, the issues are, of course, to make it space qualified, to make it lower mass, to make the solar reflectors thin film. But all of those approaches are fundamentally proven and available today. And in fact, all of the space solar power concepts require no new physics. They're all physics that have been proven over the last years or the last decades, and as a consequence, has an issue with engineering, with development, but not the basic principles of either SPS Alpha or other concepts.
Got it. It's just the economics to work out. Martin, how is what you're doing or you're planning to do different? You know, you're also looking at targeting large scale geo and MEO systems. What's the economic case for space solar, and also, you know, going straight to higher orbits compared to, you know, incremental LEO deployments?
Yes. So, as John says, this is an engineering challenge, but I think an even bigger challenge for the RF systems, which, by the way, are the technology we need for this 24/7 all-weather grid scale energy for Earth, is financing these systems. It's been one of the blockers, I think, because the economics of space-based solar power rely on very large systems in a high Earth orbit. As John was describing, putting them into a high Earth orbit is important because then you get very high utilization. Low Earth orbit, as we'll come on to, has its place. It's but the ultimate systems. These are hundreds of megawatts or gigawatt systems, need to be in a high Earth orbit for high utilization. They are then, because of diffraction physics, necessarily large to get the narrow beam and an acceptable size of rectenna on Earth. Then you have a financing challenge, because if your first systems are many billions of dollars, you've got very high cost of capital for early infrastructure. It's just really difficult to get that financed. So we've been working, I think, we collectively, the community, and certainly Space Solar, have been working on a financing roadmap combined with our technology roadmap to make the financing possible. And we certainly start off in a low Earth orbit with a minimum viable product, and we found a really exciting client for the energy. The challenge there is that the systems, whilst they're relatively small, they're not very economic. So you need to have a client which is prepared to pay quite high energy costs. We've found one, but then quite quickly we go that's proving the technology, the operations. It's proving also the financing, getting the investment community used to this as an investment class, and then we're quickly going to the geosynchronous orbits.
Thank you. And why do we need to look to space for our energy anyway? How does it make sense versus terrestrial energy sources?
Okay, yes, a really good question. So our energy demand globally is going to quadruple over the next 25 years. It used to be double, but latest analysts are saying it's going to be quadruple, and that's because of all of the kind of AI and other technology really accelerating. And so this is, at the same time, most countries are trying to move away from hydrocarbons. It's not a transition yet. Only 4% of our energy is delivered by wind and solar globally, despite trillions of dollars. And increasingly, there's a realization that the weather-dependent renewables, wind, solar, firstly, they make the energy very expensive. I'm talking from the UK. We are we've tested to destruction this theory that wind and solar are cheap. We have the most expensive energy in the world, 4 times that of the UK and of the USA, and of course it's a real blocker to economic growth, and as well as people's livelihoods and quality of life. So the other challenge of wind and solar and batteries is their low energy density. That means you need huge amounts of stuff, tons of minerals and mining and refining for every kilowatt hour of energy you generate. And this is huge, 2,000 to 7,000% more critical minerals, depending on the mineral, than equivalent hydrocarbons. Mining is not going to accelerate by that amount, and indeed, it's the environmental impact, the geopolitical challenges, and so forth are so. You've got other really important environmental geopolitical barriers to that scale up, and enter space-based solar power. And it has really, I think, 4 huge advantages. So firstly, cost. It's going to be the cheapest form of energy. John's just completing a really landmark study, which has reinforced this. It's one of a number of studies that have been done over the last few years. It's got the capability, so it provides this base load. It's dispatchable. It does that very, very high value grid balancing, and it's exportable wirelessly. Thirdly, it's got very low environmental impact, half the carbon footprint of terrestrial solar, 1,000 times less use of those critical rare earth minerals than the wind solar batteries. And fourthly, it's scalable. So because of that hypermodularity that John described, these are going to be built in gigafactories, the modules assembled in space, and we can be commissioning tens of gigawatts per year. Really will have global scaled up impact. And none of those really are and that's why we can't get to the clean energy future with our current technologies.
Very good. Thank you. All right, Colby, Etherflux, of course, is targeting LEO, and your venture recently raised $50 million as you prepare for an in-orbit demonstration next year. What are the advantages of LEO for something like this?
Yeah, thanks for having me, Jason. And just to give a quick overview of our company for those that aren't aware, we were founded in 2024 by Beju Bhatt. He's one of the co-founders of Robinhood. We're based out of San Carlos, California, so we're in the Bay Area. We've got about 30 employees. We've actually raised $60 million now to go after this. We've been awarded one R&D contract by the government from the Operational Energy Capability Improvement Fund. And we booked our first launch with SpaceX happening in 26. And so, I think your question around Leo and us taking a constellation approach kind of goes to who our customer is. And we're planning our first customer to be the US military. And, of course, lower launch costs enables a constellation. But when you think of what the military needs, they need resilient, redundant power, and they need global reach. So especially as you look at challenges in the Indo-Pacific, trying to get ships with fuel and trucks and generators into these island chains is going to be a real challenge. And I think if we're able to just send power where it needs to go, I think that's really compelling to them, which is why we've been given a contract, and there's a lot of demand. Another big advantage of Leo is it's, as John pointed out, it's relatively cheap and quick to send a satellite up. We're going to send a satellite up next year. I think a lot is going to go well. Of course, there's going to be some things that maybe don't go as planned that we learn from, and we can then, once again, quickly and relatively affordably put another one up, and you iterate on that. So you kind of work out some of the challenges before you decide to scale.
Very good, thank you. And yeah, and most SBSP concepts use microwave transmission, but you're betting on lasers. Could you outline the advantages and challenges of that approach and the niche you're aiming to serve there?
Sure. So lasers or microwaves, they both have trade-offs, no matter what way you look at it. But I think for us, if you're trying to serve the military, lasers make a lot of sense. It meets their needs better. And what do I mean by that? If I'm using lasers and optics from Leo, you can send a really small beam spot down to the ground. Think a couple parking lot spaces. So that lets you send power down to small form factor receivers globally, if you're taking the constellation approach. And so for the military, if they were to put one large stationary receiver in a contested environment, that's quite a target for the enemy. What they value is having many small receivers with many satellites able to send power to disperse forces wherever they need it. So it sort of suits our customers' needs as we see it.
Guys, is it fair to say that lasers and microwaves, that they're not competing but complementary in this market?
Yeah, definitely. I mean, like I said, I think there's trade-offs to both, and we're not opposed to using microwaves. We just think for this initial concept of operations that we're going to deliver to our customer, lasers make the most sense. But I think there's concepts where both have applications here.
Great, thank you. And John, before we get to Karen, do you want to just outline maybe the big regulatory differences between the two technologies there? I'm sure you've looked at that both.
Right. So with regard to the microwave side, there's an obvious challenge in terms of the potential for interference with other uses of the radio spectrum. And so this is the number one issue that has to be resolved. There are appropriate parts of the spectrum called bands, the industrial, scientific, and medical bands that have been set aside for R&D purposes. Those are being used now for microwave wireless power transmission technology development. But for operational systems, there will be a need to go through the International Telecommunications Union and get spectrum set aside. And fortunately, these wireless power transmitters are very narrow band. It's a very tight, sharp part of the spectrum. It's not spread all over the place because it's a solid state power amplifier, so very precise. But it's got to be set aside, and it's got to take into account a variety of users of spectrum. With regard to the laser applications, the application of lasers, you don't have the same kind of potential for interference with other users of light, but you have to be concerned about health and safety matters, about the potential risk to retinas and to for glints, for the possibility of inadvertently blinding someone. So there are health and safety concerns that have to be worked through, as well as the same kinds of safety regimen, so that your receiver is not going to be sitting. Although it's the size of a couple of parking lots, it's not going to be sitting in downtown. It's going to be in some location where it's appropriate to the application in the case of the laser, and because of the scale, outside of a community, probably by some kilometers or tens of kilometers in the case of the microwave application. So there's the regulatory matters for both kinds of systems. There are health and safety considerations, and there are public perception issues that have to be resolved, especially to get the kinds of global market penetration that is crucial for either kind of space solar power to really make a difference.
Brilliant, thank you. I definitely want to dig into that a little bit later. Karen, you've taken a neutral comparative look at SBSP Ventures. Where is the market most active right now? And what is your take on the pros and cons of these different approaches, just broadly speaking?
Okay, well, I think there's two camps here. There are the solution providers. They're very focused. They're enthusiasts and advocates. This is a group that's very committed, and it includes philanthropists that are actually outrunning venture capitalists in terms of donations. The Bren family, for instance, donated over $100 million to Caltech's space solar power project. So you have these focused solution providers looking at space to Earth transmission, and that includes Aetherflux, who's here looking at a practical niche market to get started. That's the first camp. Then you have what I'm calling the incrementalists and opportunists, and this group believes that we should start incrementally. Near-term reachable goals would be space-to-space transmission. I actually think that will help move the needle for space to Earth as well. Starcatcher is a good example of in-space energy grid that can eliminate power constraints for satellites. It can increase longevity. There's also another group that just started up called Guru Wireless, and it's a group of former Caltech folks that are looking at small UASs and how to power them through wireless power beaming. That group is on the edge, but I do think it will actually advance. The third group is not really a market proponent, but it's important to understand. This is a group of skeptics and competitors who don't really believe we need a portfolio approach to energy. We absolutely need redundancy. We need different types of power for different types of regions and markets on the planet. And this includes fusion and nuclear advocates and other terrestrial renewable industries that are doing quite well. But in fact, if you look at the growth of the solar energy industry on the ground, that's actually a terrific partner down the road, because the same utility scale solar farm taking up thousands of acres could be used for a receiving antenna for space-based solar power. It would give that facility 24/7 power, when right now, of course, they have to deal with day and night issues, et cetera. It's not baseload now. So I think in the future, we're going to start to see some compatibility and partnerships emerge from this.
Yeah, there are many ventures chasing this market, and we don't have room on this panel for all of them. Do you think there'll be a winning solar power satellite design, or is there room for multiple competing ventures here?
So this gets down to radio frequency, and the selection of RF has a cascade effect through the entire architecture. I find it hard to believe we're going to have a lot of different areas of spectrum to play with. So ultimately, what's set aside in terms of spectrum is going to probably dictate the type of architectures that will eventually emerge. And that's in play. And it takes a long time for the International Telecommunications Union to get something on its docket and then deliberate over that. So we're years away from that happening. But in the meantime, we have various operators working for focused markets like Aetherflux for the military.
Thank you. I know you've also noted that spectrum regulation and public acceptance as potential hurdles. Can you maybe expand on the steps needed to address this? Also, want to give Colby a chance to talk about the safety aspect with lasers too.
Well, it's microwaves operate at certain frequencies, but the frequencies that we're looking at are too low to, cause cancer. They're non-ionizing. So I think we're going to have to go down the same road that the cellular industry went down in terms of safety issues. And it would be a huge mistake to downplay the public's concern regarding safety issues. They need to be addressed head on, and we need to go through all the wickets to get approval for that. And that includes some studies. The Food and Drug Administration here in the US is comprised of physicians, scientists, and engineers. They regularly analyze various scientific studies and publications. I'm hoping that they can weigh in, just like they did with the cellular industry as well.
Thank you. And Colby, have you encountered any early regulatory or public engagement challenges in your program so far, and what are you doing to address that safety aspect of using lasers to do this?
Yeah, sure. I mean, our system is designed to be safe, and it's been at the forefront of our design since the beginning. One of our first hires was actually a laser safety officer, and we're trying to build it out with redundancy in mind. So it starts with the software where you're integrating with databases, you can deconflict airspace, and then it gets to the system level where the satellite is connecting with the ground station. If there's anything that interrupts a beam, you can cut it off. But how we're getting ahead of it and making sure that everybody is on board is being very proactive by talking to regulators, sharing with the FAA, the FCC, like, look, this is what we're doing for our initial missions, and this is where we want to go long term. What are your concerns? And then how can we collaborate together to make sure this is done safely and effectively? And we're only going to operate in places where we're allowed to do so and where it's safe to do so.
Brilliant. Thank you. Great stuff. Okay, so before we get on to audience Q&A, I've got some more big picture questions for the whole panel, and everyone just please feel free to jump in for any of these. And firstly, on use cases in early markets, beyond commercial baseload power, I'm curious, what are the most promising applications for this? And Colby, you mentioned, you're targeting military. Are there any other areas that this could be of interest? And Martin, you mentioned you have a client. I don't know if you can talk much about that client at the moment, or other markets you might be.
Sure. The kind of early markets are really important. Our early client. So if you put a satellite into a polar orbit, low Earth orbit, the sort of clients there, polar research stations, pay insane amounts for their energy. They find it very difficult to decarbonize. So we're working really closely with the British Antarctic Survey, and so forth. I think there are a number of early markets where particularly they need off-grid power. So decarbonizing iron and steel with very affordable electricity is key. I mean, data centers are the key topic where there's insane growth. Data center companies buying up nuclear power stations, city-scale power stations, just to power one data center. And again, you can envisage a rectenna providing hundreds of megawatts to those things off-grid. And the other beauty of off-grid is that typically grid connections take many years to realize, and so this is a big bottleneck for the scale up of data centers. Other markets, again, small island nations, really finding it. They have very high energy costs, and remote communities, particularly in Asian and African nations, where the space-based solar power really has the potential to democratize affordable, abundant energy access, which is just the unlock for prosperity in those countries.
Thank you. John and Colby, anything to add, maybe on the humanitarian aspect or any other markets?
Yeah, if I may, just the so for example, a space solar power system like SPS Alpha deployed in an orbit, say at the equator in geostationary Earth orbit, at the latitude of Kilimanjaro, as an example, could serve markets, not all simultaneously, but could serve markets as far south as South Africa, all through the sub-Saharan African countries, the Middle East and North Africa, Europe, Poland to London. And so one of the huge advantages for the commercial megacities application is the ability for one power station to serve both the highly developed countries within its field of view and the lesser developed countries, and to switch between these in less than a second. And there is no other green energy solution where a single investment championed by the financiers and governments in the developed countries could serve simultaneously the poorest countries in the world. Same is true in the Americas, same is true in Southeast Asia. And so these satellites have the opportunity to not only be for the wealthiest, but simultaneously, well, not simultaneously, but within a second, to send power to the poorest of peoples within its field of view, the poorest of markets. And this is a complete transformation where in today's energy market and historically, I get mine and you're just out of luck. In this case, one system with multiple receivers could be for many different countries and customers.
Brilliant.
May I add to that, Jason? So we did a bit of work with the Middle East, and they have potentially really cheap solar in the day, but insanely expensive at night. And here again, that ability to switch the beam within a second means you can power Northern Europe in the day when it's all overcast and no wind, and then switch it to the Middle East or African countries at night, which are so it's supremely flexible like that.
Wonderful, thank you. Colby, anything else? Just the ability to just be.
Karen's trying to get your attention, Jason.
Oh, go ahead. Sorry, Karen.
I was just, no, that's okay. I was just going to add to Martin's comment. Another insane thing is just the fragility of the grid around the world. In addition to data centers, the adoption rate for air conditioning is huge. And we have these mega cities with millions of people. New Delhi and Lagos have populations almost exceeding the entire state of Texas. Very congested, lots of air conditioning, growing urban heat islands. And if the power goes down, a lot of deaths would occur. And in fact, heat is the #1 cause of death, weather-related death. So I see this as being a way to help in those hot spots around the world as needed.
Brilliant, thank you. Yeah, no, it's very interesting to think about the knock-on impact of once this capability is in orbit. What could it open up? That what are the capabilities that it could then unlock, and then where does that go? It's very, very interesting to think about. All right, well, shifting back to investments. As I mentioned at the start, a lot of money has recently been flowing into SBSP. Are we seeing the start of a sustained investor wave or a hype bubble even? Karen, maybe you can provide some market context there.
You're on mute, Karen.
With the hype bubble, you only know it's busted after it bursts. So it's hard to, I'm going to, not directly answer that, except to say that I don't think we've reached hype yet. In fact, I think this application has been actually rather marginalized compared to some other applications out there. I think it's incredibly important to look at this and our energy needs, especially something that's so infinite. But as we look at the venture capitalists and where they're putting money, I was very encouraged by Etherflux. I think, but I also think that the incremental opportunities might get us there. These are the, space to space refueling and possibly Earth-based wireless power beaming. Money will flow into that. And I think space-based solar power will be a recipient eventually of some of that research and some of those deployments.
Very good, thank you. John Martin, I guess what you're going to say, but anyone want to weigh in?
Yeah, I'd just add to Karen's thing. I think the next big thing in space, which is already starting, is the ability to build large infrastructure in space. Which the risk is it only goes at the pace of government funding, and what space-based solar power does provide this huge market demand driver for that. The societal need for clean, affordable, abundant energy. And so I think that's a really critical one. I think there's some really interesting and important defense applications. You've got this very large aperture and a very high on the high ground, and so we've got a lot of interest also from the energy sector for, as Karen says, sort of terrestrial power beaming in hard to transmit places.
Colby, does the development of SBSP need a big international government-led collaboration, or is it really the realm of startups and VC funding?
Well, I mean, I think the private sector can will this into existence, but public investment, public partnership is going to accelerate the timeline, and I do. I mean, I think there will be a collaborative, government to government effort in space, as there are for most space applications right now.
John, what do you think of the government role in all of this?
Yeah, so I wanted to just comment that with an anecdote. In circa 2016, I went to a VC event up in the Bay Area, which was sponsored to discuss ETO, Earth to Orbit ventures, and that was a boom. That was more than a bubble, an enduring investment. But most of the people who were being pursued, that was over 100 individual ventures, and there's not a market for 100 individual launchers. But what Beiju Bot has done, what Aetherflux is doing, is really critical to creating the environment for space solar power investors of all types, but we're not there yet. And I think it's because of the reliance on a visionary individual like Beiju, as opposed to a compelling requirement for venture fund managers that you don't have a successful fund unless you've got a reusable launcher or low-cost launcher. We need to get to the point where VC funds are not going to be viewed as successful unless they have at least one space solar power venture included in their portfolio, and we're not there yet.
Interesting. Okay, thank you. And when will SBSP be commercially viable? And what apart from the investment, what single shift will make the biggest difference to get there? Are we talking about launch costs that still need to come down, Starship or another super heavy lift rocket coming online, in-orbit robotics, etc.? What do you think will really move the needle?
I want to just bring up a recent Caltech study about Starship and why it is such a game changer for something like space-based solar power. They did a study and looked at what would it take to introduce 559 modules, space solar power modules, into GEO. And for a Falcon 9 to do it, it would take, let's see here, I have the numbers here because I'm trying to remember, 280 launches. For Starship to do it, it would take 11. And so the levelized cost of energy goes from 777 cents per kilowatt hour down to 9.4 cents per kilowatt hour. And John mentioned earlier, it's an order of magnitude. That's actually more than one order of magnitude. So Starship is truly a game changer with this, and that's going to get the attention of investors. Now the art of the possible has moved.
Yeah, I would go after a calendar date for you, Jason, and then I'll stop for a second. I don't think that the Beiju and Colby and the Aetherflux team are planning to be working on this for decades without making progress. I think they're talking months to years for real progress and for the potential for a system. I want to just make the argument that for many of the microwave space solar power systems, the same kind of pace is possible. and it depends on the investment. And I'll just say, it's not decades, it's years, but and it depends on key infrastructures. But making progress when the thing that you're going to build is on the scale of a small sat, not an aircraft carrier, it completely changes the dynamic in terms of the R&D scale, pace and scale of R&D, and the pace and scale of creating the manufacturing infrastructure, the factories, and the skilled labor. And so 5 years, 8 years to a meaningful scale test in space, 7 years to 9 years for a large hundreds of megawatts to thousands of megawatts space solar powered platform. It's literally only a question of money and not a question of fundamental research.
Colby Martin, is that line of your
Space
timeframe?
Solar's,
Yeah.
Space Solar's roadmap is very similar. We're going to have a pilot plant within 5 years. This commercial revenue generating with the Polar research kind of a year later, and the big systems within a decade, and that's a because, as John said, our system called Cassiopeia has this hypermodularity. We're working with partners who've got all of the technology already there, the lightweight photovoltaics and so forth. So it's just engineering them into this system, integrating them cleverly. And so there's a really viable pathway there to do it. And I agree with John, it's about the pace of finance. And if we view this as an energy infrastructure, not space, this is quite small beer compared to large scale energy infrastructure, but it's big compared to space. And that's perhaps the different lens we need to look at it at.
And Jason, I would just add that I really think it's the power of capitalism. If you can demonstrate that this is feasible today and that the business case closes with the cost of launch going down, modern software, better manufacturing, as has been discussed the whole call, and you can show there is a commercial opportunity, private capital is going to continue to pour into this space, and it's only going to accelerate the timeline. And so I think like capitalism is what is going to drive investment and make this a reality, because realistically, space has been a lot of government-run, funded efforts over the decades, and I think that's changed in recent years.
Thank you. Okay, well, zooming out a little bit then, maybe. These will also be strategic assets in orbit. How vulnerable are they in a contested domain, and how can they be defended? Is that on your radar? Is that what you're thinking about right now?
That's something we certainly think about, and we think we have a major advantage taking a constellation approach. With a lot of small satellites, a lot of small ground stations, receivers everywhere, it's going to be very challenging for somebody to take all of that down at once. And the reality is we can continue to manufacture ground stations, manufacture satellites, and continue to launch them. And I think that if somebody wants to, compete with the United States in a conflict in space, I think we're going to out-manufacture them, and we're going to be just fine.
Martin and John, you're thinking about big, juicy targets up there. What can be done to protect those?
So essentially, so very much along the same thought line, but a different metaphor. So in Colby's case, it's like trying to in space to deal with a large school of fish with a spear. It's hard to deal with a large school of fish with a spear because they can scatter and they can do everything they're going to do. In the case of these hypermodular microwave systems, they involve literally 1 million modules in a few families manufactured in the hundreds of thousands of units. And you can readily imagine going out and shooting holes in a coral reef. But the coral reef is going to survive. So these hypermodular large platform concepts, they involve such enormous levels of functional redundancy that it would take an extremely large scale and pervasive event to harm them. Now, one of the questions in the Q&A, I'll just leap to it, has to do with coronal mass ejections. And EMPs are quite similar in terms of their potential risk to all manner of space systems. So I think one of the key issues in this one that we're looking at is how can a solar power satellite comprising, say, 1 million modules huddle up, sort of like hermit crabs. So you don't have electrical connections going across large distances. You don't provide large antennas for either EMP pulses or coronal mass ejection voltage if impacts. And you sort of huddle up. You're not going to sit there and continue to operate without effect, but you want to survive the event and come back online as quickly as possible. And so for either a threat caused by humans, like an EMP, or a natural hazard like a coronal mass ejection, it's got to be planned for, it's got to be designed in from the beginning. And the goal has to be not to somehow defeat it, but to survive it and to come back online as quickly as possible. And to anticipate for the coronal mass ejection, the impact on the ground is going to be so huge that every asset is going to need to be thinking about this. All these advanced electronics be thinking about this in the coming years.
Just to add to that, and pick up on one of Karen's points, that we need a diversity of energy technologies. This has different vulnerabilities, and so it really is good as part of the energy system. We've been working quite closely with Space Command in the UK, the top of the shop there. They view this as really actually pretty resilient when we talk through the issues. I think part of resilience is being able to bounce back quickly from a catastrophe. And of course, the hypermodularity means you've got a new satellite, 100 megawatts, gigawatt satellite recommissioned within a year. So it's nothing like having a complete wipeout of a big power station. And the other sort of aspect of vulnerability, I think, is the security systems that we need for the control of these systems. Again, we've been working very closely on all of the security protocols, and part of that is this retro directive control system and the integration of the security system so they can't be diverted or disruptive.
Fantastic, thank you. Right, looks like it's a good time to pull in some audience questions. Dan, looks like we have quite a few coming in.
Yeah, thanks everyone in the audience for submitting your questions. We have a whole lot that we're not going to have time to get to, so I'm going to jump right in. We were just talking about resilience, and one thing that came up a couple times among the audience questions is what happens when there's too much sun. I mean, if there's, say, a coronal mass ejection, like the Carrington event, is there a plan for resilience in that regard as well? All of these questions, as far as I can tell, were for anyone. So
yeah, and I already spoke to that a few moments ago, in particular, because I noticed that question came in, and the answer is absolutely, and absolutely have to consider those types of events and how best to recover and come back online following such an event, and recognizing the impact it's going to have on terrestrial systems as well as all space systems.
Seemed like a fun hypothetical I wanted to call attention to. There were also a number of questions and comments questioning the military applicability and military interest as customers of this. So I'm curious if you can talk a little bit more about that cost effectiveness degree. There were people asking about the Starship price quote, for example, and if there are other foreseeable customers for this that might be able to help drive this industry and this technology forward. I know you talked about venture capital a little while ago, but curious if there is a sort of clear pathway there.
I just want to, oh, sorry. I just wanted to bring up one thing about the military aspect. The military performs quite a bit of humanitarian relief. And in that regard, John mentioned earlier the ability to, the hermit crab approach to protect yourself. At the same time, a humanitarian approach, play well with others. And I think that's going to help space-based solar power. Be a good citizen of the world, beam to places on the planet that are desperate after a post-disaster kind of issue.
Anyone else?
there's really a lot of military applications, from powering foreign operating bases to beaming to autonomous systems. Think keeping drones aloft indefinitely to really extend your range, endurance, and lethality. And so I think from a military point of view, the ability to send energy to small receivers, basically wherever you want, this is not a solution in search of a problem. There's a lot of ways that it can be used creatively and effectively to sort of deter threats and to accomplish their mission.
Yeah, I'll just jump in, Martin. I apologize. I just want to say, though, that I think Karen's point, which is a really good one, is that although there are applications in the military for large-scale space solar power, not speaking to the market-specific ones, the value of I'll say the soft power character of space solar power assets and the importance of those to the global community. I think these would be the last resources, the last assets that anyone would want to tamper with, because they are of such immense importance to not only the country that might launch it or might lead the project, but to all the customers. And so it's like I'm going to do something that wipes out cows. Everybody benefits from cows. I mean, so wiping out cows is so self-defeating, or fish, or it's an unthinkable thing for anyone to contemplate. And I think space solar power has the potential to be similarly valuable to different markets and ubiquitous and so important that you'll want to have your struggles without bringing that card into play, because it's just too damaging to the whole.
Let's hope everyone's logical there, huh? Yeah, and someone shared in the chat a projection of 6 billion people living in cities by 2050, talking about heat islands and the essential nature of air conditioning, right, that Karen was talking about earlier. But to piggyback off of that point, you talked earlier in the conversation about public trust, right? And the steps that are needed to ensure that health concerns are addressed and other concerns are addressed. Someone asked if there are dual use implications of this technology, referring to space technology that has some use but could also be military or a weapon, right? They're curious how much of a stretch it would be for space-based solar power to have a dual use, but also I'll add, how do you address those concerns, right, with a new technology?
It might be worth kind of splitting that into RF and laser, but one of the characteristics of the RF systems is that they're supremely difficult to weaponize. The energy density is just not there. So safety is really fundamentally built into these. And so whilst they have dual use in that they could provide power to kind of large military bases and so forth, and deployed operations, as Colby was discussing, they're not going to be weaponized. That's perhaps not the same for the laser systems, but the public trust is really central. We've done a lot of public outreach, and including some big structured surveys of the public, which was organised by the Royal Society here in the UK and Ipsos, the polling agency. And once it's explained the characteristics, this is not going to be large scale infrastructure in people's backyards, why it's safe, there was just a huge, strong support, and I think this is encouraging that people recognise the importance of reliable, abundant, cheap energy, and that it's not going to be not going to provide an NIMBY backyard. It's not going to pose safety problems. We've seen really strong public support so far. That obviously a big journey to go through, and Karen's absolutely right. We've got to be. This is a really important thing that we get the messaging right, especially as early systems are deployed and so forth.
Great. Keeping an eye on the clock,
I
I'll
could-
ask. Oh, yeah, please.
Sorry, just 10 seconds. The other aspect, whether it's a microwave system or a laser system, none of this is hidden under a mountain where there's uncertainty as to what's actually being done. All of these systems are going to be in space. Anybody can look at them with a telescope. If it's got a huge optic and it could be used as a direct weapon, you're going to be able to see it. If there's something quirky with the microwave satellite and it's not quite right, you're going to be able to look at it. All of these things will be absolutely open and inspectable by anybody in the international community in space or on the Earth. And so that makes them almost uniquely transparent in terms of what the systems will be capable of doing. And I think there have to be agreements, there has to be an international regime, but I think that the risk of uncertainty, which we've seen played out in the last 6 months, vanishes if everybody can see everything.
Great. I'm going to ask one more quick question and then hand it back to you, Jason, just because I'm keeping an eye on the time. Rob Mann asked at the start of the conversation, how can we, as regular citizens of the space-based solar power community, help to move humanity closer to the development and deployment of SBSP? So aside from public trust, what do you want to see from the public?
Demand that your investment fund, whether it's your 401k or your family trust fund or whoever it is, or you should be demanding, why aren't you investing in space solar power? Why isn't this part of your portfolio? From my perspective, that kind of conversation coming grassroots into investment decision makers would have a great and positive impact.
Talk to your MPs or senators,
On the government side. Yep.
Great. Then I'll hand it back to you, Jason, for any last questions or thoughts.
Thank you, Dan. Yeah, and if you want to continue the conversation, you can connect with our speakers through their company websites and, of course, follow Space News for the latest. That is all the time we have for, unfortunately. Thank you to our panelists and to all of you for joining. Thanks again to Position Sciences for sponsoring this webinar. Space-based solar power is no longer science fiction, and as we've heard today, the next decade could be transformational. So until next time, take care.